All right, my friends, let us master ether channels. We've got switch 1 and 2 here and 3 trunks between the two. And here's switch 2 with show interface trunk. This being a 2960, it's running in auto mode by default. And our other one is a 2950 and it's running dynamic desirable by default for trunking mode. So our trunks are up and running, but we've got 3 trunks. But if I run show spanning 1, or show spanning VLAN 100. Let me bring that up just a tad. We can see that on the non-root switch, 2 of the ports are in blocking mode. So right now we're only using 1 trunk, and we're going to remedy that right now. Also want to remind you of an old friend here, because let's say 3 trunks would be a little bit of typing if we put each trunk in the ether channel manually. But what if we had 8 of them? We wouldn't want to do them one at a time. That would be a lot of typing. Remember your old friend, the interface range command? Now whatever I type in is going to be applied to interfaces 10, 11, and 12. This is a really handy command. Just watch your spacing here, because once in a while the iOS is going to yell at you if you don't leave spaces here. It doesn't like that. But just get used to that command, because it is a huge lifesaver. Let's say on the exam or in a job interview, if you came in a job interview with me, I put you in front of a switch and say, hey, I need you to put all the ports on this switch into auto mode or 100 meg speed, whatever, and I need you to do it in less than a minute. Well, I'm a very fast typist, but I couldn't do that in less than a minute with all those ports on an individual basis, but I could do it with interface range just like that. So let's go ahead and put our channel group command here. Not a lot of numeric choices here, 1 through 6. We're so used to seeing, like 1 through 46 zillion. But just 1 through 6 here. You do actually have to type the word mode. And I'm going to make a quick video after this one going over very few details, but just quickly comparing PAGP and LACP. These are 2 ether channel negotiation protocols. Most of the time in the real world, you're just going to turn the thing on. That's what I always do. I don't see any reason to get into the negotiations, but every once in a while, in very specialized situations in real-world networking, you might have to do that. But again, LACP and PAGP are your ether channel negotiation protocols. I'm just going with on here, and that's it. So it's saying, notice it says creating a port channel interface, port channel 1. And we get some messages there, so let's go on over to, let's do the range command here too. Notice that I used a different channel group on each switch. Channel group numbers don't have to match between switch A and switch B, so to speak, or in this case, switch 1 and switch 2. But of course, if you're putting 3 ports into a channel group, you have on a switch, you have to use the same number for each interface. So let's see what we can see. Do we have an ether channel yet? Let's see. Line protocol, change state to up. Things are looking pretty good so far. Let me show you what I meant about the show config, as we've seen a couple of references to port channel already. And this is exactly how you're going to see it in your config. Interface, port channel, and then whatever number you gave it. So ether channels are created with the channel group command, which make a port channel appear on your configuration on your switch. So there's our individual commands on 10, 11, and 12. And let's run show interface trunk. And it looks like we are in good shape here. So we've got a PO5 now instead of fast 10, fast 11, fast 12. Let's go over to switch 2 and verify it. It should be perfectly fine. And you can see that it is. It's port channel 1, because of course we gave it the group channel 1. A quick real world note here. If you are a little slower with this configuration than I was, going from one switch to another and doing the commands and everything, nothing wrong with that. But when you're done, check your individual physical interfaces and make sure they didn't go into error disabled state. Because what can happen is after a certain period of time, let's say here with ports 10 on each side, what can happen after a certain period of time is if channel 10 or interface 10 on one switch is configured for an ether channel and it's not configured on the other end, the port's going to go into error disabled mode on the end where you configure the ether channel. So it's a hard thing to replicate sometimes. I didn't want to do it here in the lab immediately, but I did want to mention that to you. It's a good real world note. I doubt that pops up on your exam, but it is something to look out for. And you know what to do about an error disabled port. Just go ahead and finish the configuration, go to your error disabled ports, shut them down, and then reopen them. That's all there is to it. Now we've got show interface trunk. Let's run show spanning. And look at this. Now instead of a cost of 19 for the one fast Ethernet port we were using on switch 2, we have PO1 under show spanning VLAN 100, and it has a cost of 9. So we've got a little over twice as much speed right now according to STP, and now of course we just have the one channel forwarding and that's it. The individual ports are gone. They've been aggregated. Now, let's go ahead and mess with that a little bit, because I did say in the theory that if a physical channel in an ether channel goes down, we don't have the whole, blocking, listening, learning, forwarding bit, but the cost is going to change a little bit. Let's check that out. And the best way to do that in the lab is just to shut a port. So let's say that port 12 just shorts out. Bing, gone. Well, let's see. Show spanning VLAN 100. You can see the line protocol message up here is referring to the physical interface. So that changed state to down, but we don't see anything here about something bad happening to the ether channel. And check it out. It stayed in forwarding mode. It's just that the cost went up a little bit because now instead of 3 paths being aggregated on this switch, we only have 2. But that's the great part about it. We lost a port, but there was no 50-second delay in the cutover. There was no cutover. We just don't have as much speed. So what would happen, you say, pardon me, if you shut another port down? Well, let's check it out. Switch is having a bad day. Just lost 2 ports. And we're going to see a couple messages about that going down, the individual port that is. But check it out. Nothing happened to the port channel as far as having to go through the stages again. It's just the cost is up to 19 now because we only have one fast Ethernet port in there. So let's say that you just came in and sat down and it's like, okay, what's going on here? Why is this at 19? What's going on? Let's look at a couple of verification commands. And we're finally going to get to use the word Etherchannel here. You don't have to be too familiar with every single one of those because there is a lot of information in here. But let's just do a show Etherchannel 1. It says it's an incomplete command. And then you still have to say, well, do I want port information, port channel information, summary, etc., one-line summary. One-line summary sounds pretty good. Let's check that one out. And it's going to tell you how many channel groups you have, number of aggregators. It's saying PO1 SU. And what does this mean? Well, the capital S is layer 2 and the capital U is in use. The reason it mentions layer 2 here, you'll notice right next to it layer 3. There is such a thing as a layer 3 ether channel that you can actually give an IP address to. That is way for your future studies, but I didn't want to show you layer 2 and not mention that. So it's saying, okay, you got a layer 2 ether channel and it's in use, and you go over here. Here are the ports that are in it, but watch your codes here. Because this is what I always tell people. Sooner or later, you're seeing something for the first time in a production network. Just remain calm. If you saw this, all the codes are right here, and it's telling you, look, fast 10 is in, it's bundled, it's in the port channel. It's telling you right there, fast 11 is down, fast 12 is down. Of course, you could have done an individual show interface and gone through that, but this is a good command to get started with. So it's telling you right now, there's a problem with 11 and 12. Let's run show Etherchannel again and see some other commands. How about detail? I'm always scared of detail. There's a lot of detail here, as you can see. And look at a little information here, though. Channel group listing, group 1. It's telling you again it's a layer 2 ether channel. 3 ports are in it, max ports 8. And if you go down here, you'll see some differences. If you're not quite familiar with the show or the debug you're using, and you've got a situation like this, look for differences. What's the difference between the port that's working and the port that isn't working? And right here you can see it's got port state up master in bundle. Sounds good to me. Down, not in bundle, does not sound good at all. And you'll notice it even says null for the port channel. And it's going to tell you how long the port's been in the current state, etc. Like I said, a lot of detail is going on here, but you can see time since last port bundled. You know, it's been 7 minutes and 29 seconds since we built it, and since it was unbundled, it's been 2 minutes 59 seconds. That's a good piece of information because, as I say often, you know, in a way, we're in the detective business in this business. You know, we can't really rely on people, even network admins who are good human beings, to always they might be not telling us the truth on purpose, or they might just not know. But sometimes when people don't know something, they feel like they have to say something anyway, and they could say, oh, well, you know, that Ether channel's been down for, you know, a day and a half. And you go in here and you run this little command and you think to yourself, well, you know, it was bundled 7 minutes, 29 seconds ago, and it was unbundled 3 minutes ago. So if I have a choice between believing a person and what I'm seeing here on the screen, I will generally believe what I'm seeing on the screen. So again, that's a handy little command, show Ether channel details. A lot of stuff going on there, but we can certainly parse through that. So let's go ahead and open those ports back and see if we have to do anything at all to get the Ether channel back up and running again. So, whoops, let's do a conf T there. I'll open them both up at the same time. And let's see, I bet we come right back up. It's something about a can't bundle, but I think that's going to be fine. Let's see what we've got there. Okay, and we're right back in business. So we just got those messages very quickly, can't bundle, etc. But I've seen that before when you first reopen interfaces. But now we can see everything is perfectly fine because our cost has gone right back down to 9 for our port channel. So there was no having to reopen any interfaces or shut them down, reopen them, anything like that. They were just administratively down. So when we opened them back up, the commands to put them in the Ether channel were still on the port. So no problem there. They just go right back into the port channel and you're good to go. So those are that's your Ether channel. It's really not a difficult configuration at all. Like I said, I'll follow this up with a video and just discuss those two protocols very briefly. It won't take you long to watch that one. So we're not going to go into a lot of detail on those. But to me, in my experience with Ether channels in production networks and in lab environments, the problems come in when people get cute with the negotiation protocols and say, well, why doesn't this work? Well, you know, maybe you're using different protocols on each end, different negotiation protocols. To me, whenever you can, if an exam doesn't tell you otherwise, and the CCNA is not going to tell you otherwise, just use on, you know, and you will avoid a lot of self-inflicted pain. That is it for Ether channels. Like I said, I'll see you in the next video with a quick discussion of those two protocols, and then we're going to march on to BPDU guard. So I'll see you on those next two videos.